Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Electrophilic addition of bromine, Br2, to alkenes proceeds via anti-addition, trans-addition, through a bromonium ion intermediate. The stereochemical outcome depends on the geometry of the starting alkene. Moving on to the next step. Identify the starting material. 2-butanoic acid is fumaric acid, which has the 2 carboxylic acid groups on opposite sides of the double bond, trans configuration. Moving on to the next step. Mechanism of bromination. Br2 adds to the double bond via a cyclic bromonium ion intermediate. The nucleophilic bromide ion then attacks from the back side, relative to the bromonium ion. And for the final step. Anti-addition to fumaric acid. In fumaric acid, E configuration, the 2 groups are trans to each other. Anti-addition of Br2 means the 2 bromine atoms add to opposite faces of the double bond. Determine the product stereochemistry. When anti-addition occurs on fumaric acid, the bromonium ion forms on one face. Br attacks C3 from the opposite face. Due to the trans geometry of fumaric acid, anti-addition produces a single stereoisomer where the 2 Br atoms and the 2 groups have specific spatial relationships. The product is the meso compound 2R3S, 2,3-dibromosuccinic acid. This is because the molecule has an internal plane of symmetry, making C2R and C3S, or equivalently C2S and C3R, which is the same meso compound. Why other options fail? Option B 2R, 3R and option D 2S, 3S are enantiomers of each other, the chiral pair, which would result from SYN addition, not anti-addition. Option C, a racemic mixture of 2R, 3R and 2S, 3S would also result from SYN addition to fumaric acid, not anti-addition. Anti-addition to fumaric acid specifically gives the meso compound 2R, 3S, confirming option A. Therefore, the correct answer is A. Therefore, the correct answer is option A.